I need to be honest with you, this changes everything. Not in the usual dramatic, overused sense, but in the rare way when reality quietly shifts beneath your feet and suddenly nothing fits where it used to. Something happened today, something NASA did not expect, something no one was prepared to see. And the strangest part, it didn't arrive with thunder or headlines or flashing alerts. It arrived in silence, through numbers, light curves, faint stretched pixels, and a long pause in rooms full of scientists who stopped talking mid-sentence as their screens started whispering a different story. It began like any other observation day. Telescopes tracked the interstellar Comet 3 Atlas just as they had for weeks. Bright, active, throwing off gas faster than any comet its size should, but still following the rules, still behaving like one single object. One nucleus, one identity. That was the story we thought we knew. But stories change, and sometimes they don't change gradually, sometimes they snap. Today, in control rooms from California to Madrid, something snapped. It wasn't loud, it wasn't cinematic, it was a subtle shift in a light curve, one heartbeat becoming two. A brightness pattern that had been consistent suddenly pulsed differently, almost as if the comet had developed a second rhythm, a second form, a second presence. Screens didn't flash red, alarms didn't go off, but eyes widened. Conversations stopped. Fingers hovered over keyboards. Something was different. NASA analysts began rechecking their instruments, not because they thought something was wrong, but because, for a moment, they hoped something was. Because if the data was right, then 3 Atlas was no longer what it used to be. And no one in those quiet rooms wanted to be the first to say it aloud. Because saying it aloud would mean accepting the unthinkable, that this object, this visitor from beyond our solar system, may not be a single thing anymore. There was no theory ready for this. No document, no slide, no expected explanation, just a slow-building realization that we weren't watching an object travel through space. We were watching something change. This wasn't an update. This wasn't a new data point. This was a transformation. And so the question began to echo, first quietly, then with weight. What are we actually looking at? Until yesterday, the story was simple. 3 Atlas was unusual, yes, bright, hyperactive, shedding mass at a rate that made astronomers raise their eyebrows, but still understandable, still classifiable, still behaving like something we could fit neatly into the category of interstellar comet. At its core, it was believed to be one object, one nucleus. One solid, ancient fragment of ice and dust that had wandered across the galaxy for millions of years before passing through our solar system. Every model, every calculation, every observation pointed back to that single, reliable identity. It was strange, but it was singular. The light curve confirmed it. For weeks, telescopes across the world, ground-based and space-based, returned a clean, consistent brightness pattern. With each rotation, there was one dominant peak, one moment of brightness where the most reflective or active region of the comet swung into view. Then it would fade, rotate, and return again. Bright, fade, one rhythm, one heartbeat, one source. It didn't matter which observatory measured it. Chile, Spain, Arizona, Australia, every graph agreed. There was only one peak, which meant there was only one nucleus, one comet spinning, venting, behaving, at least fundamentally, as a whole. It vented gas and dust, of course. It flared a few times. Its activity spiked dramatically near perihelion, losing nearly 40 times more water than predicted. But none of that broke the basic assumption. It was still one object, just a very energetic one. Its jets were mapped. Its outgassing patterns modeled. The thrust pushing it slightly off its expected gravitational trajectory was measurable, traceable, even predictable. Everything it did could be explained by the behavior of a single, irregularly shaped, but intact, cometary nucleus. Scientists built simulations based on that premise. Orbit models, structural stability predictions, activity estimates. All of it was rooted in one idea. 3 Atlas was one body, one nucleus, one identity. That assumption gave us comfort. It gave the data structure. It made the comet fascinating but not chaotic, strange but not unknowable, and then, quietly, it stopped being true. Because as of today, that assumption is dead. And the story we thought we knew, the story of one comet, one form, one consistent identity, died with it. In astronomy, light is language, and one of the clearest ways that objects speak to us is through something called a light curve. Think of it as the heartbeat of a space object, a pulse of brightness that rises and falls as it rotates, shifts, vents, or changes. It's not just a GR. APH, it's a living signature, a way to understand shape, stability, structure, and identity, not by looking at the object itself, but by studying the rhythm of its light. For 3 Atlas, that heartbeat had been remarkably stable from the beginning. Every telescope, every observatory, every data batch told the same story, one peak per rotation, one moment of brightness where a dominant reflective or active region faced Earth and the Sun. Then it would fade, rotate again, and return to the same brightness peak like clockwork. Bright, then dim. Bright, then dim. One clean heartbeat, repeating in perfect rhythm. For weeks, that steady pulse reassured astronomers. It confirmed their belief that they were observing one nucleus, one solid object. Even though the comet was unusually active, losing mass faster than expected and producing jets stronger than typical comets of its size, none of that disrupted the fundamental pattern. The light curve remained loyal to one truth. 3 Atlas was intact. It was whole. It was singular. This consistency meant the comet wasn't structurally breaking, wasn't tumbling chaotically, wasn't pulling itself apart. No irregular second signal, no doubled peaks, no distortions, just one heartbeat, one identity. And when data from different telescopes aligned perfectly, when graphs from different regions of the world matched exactly, astronomers felt confident. Nothing dramatic was happening inside. Nothing was fundamentally changing. Until today. The new light curve arrived, and before anyone could analyze or interpret it, they could feel that something was off. The heartbeat had changed. Instead of one peak, there were now two distinct pulses of brightness during each rotation. It wasn't noise. It wasn't an error. It was clear, repeated, and undeniable. The comet's light signature had split. For scientists, this was not just a data anomaly. It was a revelation, because a light curve does not simply change like that without cause. Something physical had changed, something fundamental. The comet's heartbeat was no longer steady. It was doubled. Today, that heartbeat changed. When the new light curve appeared, it didn't whisper, it disrupted. Instead of one stable peak per rotation, there were now two distinct, repeating pulses appearing every time 3 Atlas completed a full turn in space. For comet scientists, this was not a small adjustment. This was a seismic shift. Light curves are not random. They don't flicker like faulty bulbs. They are precise reflections of form, structure, and activity. When one heartbeat becomes 2, it means something physically, structurally, fundamentally has changed. In comet science, a single light peak means a single rotating body, one nucleus, showing its most reflective, active, or bright region once per spin. 2 peaks mean something entirely different. It means the object is no longer uniform. It means there are now 2 dominant brightness sources, appearing at different times, reflecting or emitting light separately. That doesn't just suggest complexity, it suggests division. There are only 2 ways this can happen. The first possibility is internal collapse. Imagine the comet's nucleus as a fragile structure of ancient ice and dust, held together by gravity, frozen pressure, and time. When this kind of body heats up during a close pass by the sun, internal voids can collapse. Material can shift. The shape can deform. Stress can bend it, stretch it, twist it into a slightly elongated or even bifurcated form. If that happened, one rotating object could now have 2 dominant active regions, producing 2 distinct brightness peaks during each full spin. It would still be one object, but now distorted, reshaped, changed from within. But there's a second possibility, one that carries even deeper implications. Fragmentation. Not the explosive Hollywood type where comets shatter dramatically in seconds. Real fragmentation is quiet, slow, incremental. It begins deep inside stress fractures, gas pressure, rotation forces, until the nucleus begins to split not apart but away. Two bodies still touching, then barely touching, then drifting. Still close, still locked inside the same coma, still looking like one object, but behaving like two. Two rotation signatures, two heartbeat peaks, two sources of light. That is why, when astronomers saw the split in the light curve, there was silence. Because when a comet's light curve doubles, its identity begins to divide. It stops being one solid body and starts behaving like two. It stops being a single object and begins becoming something else. The comet's identity started splitting. Astronomers don't rely on single snapshots when studying objects like 3 Atlas. A single photograph can hide more than it reveals. Noise, atmospheric distortion, faint features, all of it can be lost. So instead, they use a process called stacked imaging. It works like this. Take hundreds of images across multiple nights, each one capturing tiny faint details that the human eye can't see. Then align them pixel by pixel, correcting for rotation, motion, and atmospheric interference. Layer them perfectly. Combine their signals. Filter out noise. What emerges is not a picture. It is truth, a precise visual fingerprint of what's actually there. For weeks, those stacked images of 3 Atlas told a consistent story. At the center of the hazy coma, buried inside the cloud of gas and dust, sat a bright, compact core, sharp, symmetric, centered, exactly what you would expect from a single nucleus venting material but still intact. No split, no distortion, one bright concentration of light, one source. Even with the comet's chaotic activity, the core never betrayed the idea of singularity. Until the latest stacked images arrived. When the new pixel-aligned frames were processed and compared side by side with earlier versions, something subtle but unmistakable appeared. The bright central region was no longer compact, no longer symmetrical. It was stretched, just slightly, not enough to look like two separate objects, but enough to break the illusion of one. The light wasn't coming from a clean, round core anymore. It was coming from an elongated shape, blurred, distorted, wider than it should be. Then came the real surprise. When scientists plotted the brightness distribution, how light intensity spread across the nucleus, there weren't just stretched edges. There were two distinct bumps, two overlapping brightness peaks sitting close together like two lights pressed under the same blanket, still too close to be clearly resolved, still shrouded in the same coma, but no longer one. It wasn't clean enough to label as a confirmed split, but it was too stretched, too distorted, too uneven to be called a single source anymore. Not a perfect sphere, not a compact nucleus. Something beginning to separate, something beginning to become two. Visually, it no longer looked like the core of one comet. It looked like the blurred outline of something dividing, slowly, deliberately, quietly. It didn't look like one comet anymore. In space, gravity is not the only force that moves a comet. When sunlight heats its surface, buried ice turns to gas and escapes violently into space. Those escaping jets of gas and dust don't just create the comet's tail, they push on the comet like tiny rocket engines. The effect is small, but over time it can slightly change the comet's orbit. These are called non-gravitational forces, and for 3 Atlas they have always been unusually strong. But until now, they were consistent. For the past several weeks, the direction of that push, those gas jets, had been stable. It came from a dominant venting region, always from roughly the same angle, always affecting the orbit in the same predictable way. When astronomers calculated the trajectory, they accounted for it. They mapped it. They could show exactly how that outgassing would nudge the comet slightly off a purely gravity-based path. Different observatories, different models, same conclusion. One primary source of thrust, one engine, one body. Then the newest orbital update arrived. Without warning, the thrust direction had rotated, not slightly oscillated, not drifted. It had changed. The push was now coming from a noticeably different angle, an angle that did not line up with the known active jet region that had been dominant for weeks. In other words, the comet was being pushed in a way that didn't match the locations we've been watching. The engine had moved or multiplied. This is not a random fluctuation. Gas jets are rooted in the surface geometry. They come from cracks, vents, and exposed ice pockets on the nucleus. They don't shift location dramatically unless the underlying structure changes, or unless there is more than one source now. That's why this change raised alarms. Because if the thrust direction no longer aligns with the known active jet zone, there are only two explanations. Either new venting regions have opened up where they shouldn't, or, more unsettling, there are now two sets of jets coming from two slightly different bodies. One engine became two. The orbit didn't just shift. It changed in a way that suggests the comet's structure, and possibly its identity, is no longer singular. There are now three leading explanations for what 3 Atlas may be becoming, and none of them are ordinary. They challenge how we understand comet behavior, especially for an object that did not originate in our solar system. The 3 theories are not guesses. They are based directly on what the light curve, imaging, and orbital force data are showing. And yet, each theory carries implications more extraordinary than the last. The first theory is internal restructuring. Think of the comet's nucleus not as a solid rock, but as a loosely held together relic of ancient ice, dust, and frozen gases, a fragile, porous object that has been floating undisturbed between stars for possibly millions of years. When it neared the sun for the first time in its long journey, intense heating began melting internal ice pockets. Some of that melted material escaped into space, while other parts refroze deeper inside, changing the comet's internal mass distribution. Empty cavities collapsed, sections compressed, internal layers likely shifted. When this happens, the shape of the nucleus can subtly change. That shift can cause new jets to open, old jets to close, and even alter the comet's spin and wobble. If 3 Atlas experienced such a collapse or internal shift, it would explain why the light curve now shows 2 brightness peaks instead of 1, why the central nucleus now appears stretched in images, and why the thrust direction is no longer aligned with its original active region. In this scenario, it is still one comet, but one that is now reshaped from within. The second theory is more dramatic and more concerning. Fragmentation. Not explosive, cinematic breakup, but the quiet kind, slow, controlled, and almost invisible. 3 Atlas may now be splitting into 2 nuclei, still touching or nearly touching, still wrapped inside the same coma, still sharing dust and gas, but beginning to physically separate. If 2 cores are forming, even just a few hundred meters apart, their combined light would overlap in stacked images, appearing elongated rather than clearly split. Their light curve signatures would merge, creating 2 distinct brightness peaks as each nucleus rotates separately. And their jets, no longer coming from one body, would change the net thrust direction, producing the orbital anomaly we now see. If this is true, it would be historic. The first time humanity has ever witnessed fragmentation in an interstellar comet, in real time, under direct observation, with telescopes from around the world capturing every moment. The third theory is complex rotational state, often called tumbling. Sometimes when comets undergo violent outgassing, they don't just spin, they wobble, tilt, or rotate around multiple axes at the same time. This chaotic motion means that different parts of the surface face the sun at different angles during rotation, making brightness patterns appear double-peaked, or even triple-peaked, even if the comet is still structurally intact. The thrust direction from gas jets would also become unpredictable, changing as the rotation shifts. In this scenario, 3 Atlas would still be one body, but behaving in an unstable and chaotic way, making it appear as if there were 2 brightness sources, when in fact it is only tumbling. Each of these theories fits some part of the data. None of them explain everything. Internal restructuring explains deformation but not overlapping brightness peaks. Tumbling explains light curve behavior but not the stretched central core. Fragmentation explains all three, but carries the most radical implications. Which one are we witnessing? Scientists are not rushing to declare anything. Their reports are careful, measured, wrapped in language that avoids speculation. They don't say the comet is splitting. They don't say we might be witnessing fragmentation. Instead, they write sentences like, "We have detected evolving morphology in the inner coma." In plain English, that means the comet is changing shape. Another line appears in the orbital documentation. Non-gravitational parameters have been adjusted to account for updated outgassing vectors. Translated, it simply means the comet is being pushed in a different direction now than it was before. Something about its structure, its jets, or possibly its number of active surfaces has changed. There's another cautious phrase. Preliminary photometric analysis suggests the emergence of additional periodic signals. What it really means is, the light pattern is no longer single. Something new is creating an extra pulse. None of these reports claim certainty. They don't confirm restructuring. They don't confirm fragmentation. They don't even confirm a new rotational state. Instead, they use language like potential secondary source, unresolved dual signature, and temporarily elongated central brightness profile, words that carefully avoid naming what the evidence appears to be suggesting. Not because scientists don't see it, but because they understand what it would mean if they said it. So for now, the official language stays safe, reserved, technical, but the silence between the lines is full of anticipation, because if this is not a glitch, not a distortion, not a momentary flicker, then it is something else. It might be evolution. That is why no one is making bold claims yet. They are waiting, carefully, watching to see what the comet does next. Does the light curve stay doubled? Does the stretched core sharpen further, forming two separate brightness centers? Does the thrust direction become even more unstable? Or does it all go back to normal? Because that answer determines whether this is just a temporary flicker in the data, or the first moment we witnessed an interstellar object changing form in real time. A one-time glitch, or a transformation unfolding before our eyes. Now every night matters. The passive observing phase is over, and scientists have shifted into active tracking mode. The comet that once simply passed through our solar system is now being monitored like a living experiment unfolding in real time. Every sunset signals the start of another night of urgent observations, another opportunity to catch 3 Atlas in the process of becoming something new or in the process of disappearing. The first priority is photometry, daily monitoring of the light curve. Telescopes across the world, from professional observatories to high-precision amateur setups, will measure the comet's brightness pattern through each rotation. If the double-peaked rhythm continues, it strengthens the case for structural change. If it sharpens further, or splits into 3, it would be undeniable evidence of fragmentation or complex tumbling. But if it returns to a single peak, it might suggest a temporary disturbance, a fleeting structural flicker rather than a true transformation. At the same time, deep-stacked imaging will continue, now with higher sensitivity and longer exposure times. Every image will be aligned, pixel-corrected, and layered to squeeze out every faint signal hiding behind the coma. What scientists are looking for is subtle but unmistakable, the separation of light sources. Even a slight gap, even a faint asymmetry, could mean the nucleus is detaching into 2 distinct bodies. Image by image, night by night, astronomers will be looking for a clear sign that one has become 2. Meanwhile, orbital analysts will continue recalculating the comet's trajectory after each observation. If the non-gravitational forces keep shifting direction, or begin to behave irregularly, it could mean that more than one nucleus is venting gas, each acting like a miniature rocket engine. That would not only change the comet's path, but might create two overlapping but diverging tracks, early proof of full fragmentation even before the objects visually separate. In the days ahead, scientists will be looking for four possible outcomes. The first and most dramatic is full fragmentation. The comet splits into two clearly separated bodies, each with its own brightness signature, its own rotation, its own tail, and perhaps even its own orbit. If that happens, it will be the first recorded fragmentation of an interstellar object in human history. The second possibility is collapse and fade away. The nucleus could crumble inward, losing structure rather than splitting apart. Activity could drop. Brightness could fall. It could weaken and eventually disappear into a haze of dust, an interstellar visitor dissolving before our eyes. The third possibility is stabilization. Something physically changed, but only temporarily. The structure settles, the heartbeat returns to one peak, the core regains symmetry, and the comet continues quietly on its path through the solar system, leaving behind only a few days of mystery. And then there is the fourth possibility, that it becomes something else entirely. Not one, not two, not disintegrated, but behaving in a way we don't yet have language for. Perhaps a binary nucleus that remains close and bound. Perhaps entering a chaotic spin state we've never modeled before. Perhaps an unstable object that flickers between states, neither fully split nor fully whole. What happens next is not theoretical. It is unfolding now, and every night of data could move the comet closer to one of those futures. The countdown isn't to impact, it isn't to approach, it is to revelation, because the next few nights could change the answer forever. There is an unspoken question hovering quietly around this discovery, one that scientists will not include in their papers, but one that inevitably forms in the mind when watching something behave in ways that do not fully align with randomness or chaos. What if some cosmic behaviors are neither fully natural nor fully intentional, but exist in a space we don't yet know how to describe? Not designed, not alive, but exhibiting patterns of response, patterns that seem adaptive. 3 Atlas is still a comet. It is still made of ice and dust. It still vents gas in response to sunlight. But what captures attention now is not just that it is active, but that its activity appears unexpectedly organized. Not chaotic bursts, but directional shifts. Not random jets, but thrust patterns that at times look coordinated. It doesn't imply purpose. It implies complexity. Could an object formed outside our solar system have internal structures radically different from anything we have seen here? Perhaps pockets of materials that react differently under heat and pressure. Layers not of uniform ice, but of unknown composites formed under unknown cosmic conditions. Meteors that react not randomly but in a sequence, triggering shifts not in one direction but in alternating ones. These wouldn't be engineered responses. They would simply be unfamiliar ones. And so the philosophical question emerges. When does natural behavior begin to resemble intentional behavior? When something alters itself in ways that appear purposeful, yet are entirely governed by physics, chemistry, and structure. Is it truly intentional, or have we simply reached the edge of our understanding of natural? Maybe this is not about intelligence or intent at all. Maybe it is about complexity beyond our assumptions. Maybe the comet is not alive, but it is not simple either. Nothing about 3 Atlas suggests consciousness, but everything about it now demands a deeper question. What if the universe behaves in ways that feel intentional, but are simply not yet understood? We are not studying a fossil of the universe. We are witnessing something alive in its motion, alive in its change, not biological but transforming in real time. We are not sifting through archived data, reconstructing events that happened long ago. We are watching a story write itself as we speak. 3 Atlas is no longer just passing through our solar system. It is reshaping its own identity while we observe, shifting from what we thought it was into something we don't yet have words for. When this began, we believed it was a single nucleus, a single form, a visitor that could be defined, measured, and categorized. Now that definition is dissolving. Its light curve no longer speaks in one voice. Its core no longer holds a single center. Its orbit no longer responds to one source of thrust. It is stretching, dividing, behaving, not like something collapsing, but like something becoming. We are watching an interstellar object evolve, not over centuries or decades, but night by night, frame by frame, heartbeat by heartbeat. It is not just a scientific observation. It is a reminder of uncertainty. A reminder that even with our telescopes, models, and instruments, the universe still finds ways to surprise us. It finds ways to remain mysterious. Because in moments like this, science becomes something else. It becomes wonder again, not answers but questions. This isn't archived or historical. This is happening right now. We haven't discovered 3 Atlas. We are discovering it live. And whatever it is becoming, the story is still unfolding.